Right. Okay. So it's our pleasure to welcome Andy Sheppard, Dr. Andy Sheppard from CSIRO, and Andy is going to speak to us on biosecurity and the role of new technologies and transformational technologies. But before we move on to that, I'd like to go through the housekeeping rules, which will be familiar to at least most of you. And that is that Andy's going to be talking, you obviously sharing screen using slides for about 30 minutes. There will be then moderated questions. And on tonight, as last week, Brian Timms, our expert moderator and wrangler of questions, won't be able to handle that role because he's been in hospital, but I'll handle that role myself. So that's the format which you're familiar with. And the other point is that the questions will be coming in on the chat function rather than being given verbally. And the chat function is there to give questions. It is not to pass comments on the quality of the chairmanship of the meeting or on the speaker, etc. So please restrain yourselves, but we will moderate the questions and hopefully have a very good discussion as in the Q&A. So I think that's all for the moment, and I'm going to move to actually welcome Andy and to give you some background on Andy. Andy, as you know, is the co-director of the major initiative between the Department of Agriculture, Forestry and Fisheries, DAF, and CSIRO. And he's had a long experience. I don't quite understand how he managed to have so much good time in the south of France, but he has. Heading research institutes there, and still has a role as a director of a major research institute over there. But Andy is also, so he's Chief Research Scientist, his formal title, Chief Research Scientist, Health and Biosecurity. He's been on numerous international committees as well as Australian committees and working groups. So he has considerable overwhelming expertise in this area, and it's a great pleasure to have Andy on board to speak with us. I'm not going to say any more. We're already 3 minutes into our time. Andy, we want to hear you, not me. So please, over to you. Thank you.
Thank you, John. I'll try and share screens. There we go. There we go. Can you see that all right?
Yes. Yes, there it is. Okay.
Excellent. All right, good. Yeah, so I'm going to give you a fairly broad, an overarching talk on biosecurity and the problems caused by invasive alien species in Australia and how we manage them, but trying to couch that into on the one hand into an international context, but also what are the new transformational technologies that are coming online to help us manage both the threats and impact from these species. Now, hopefully just try, there we go. So I'd like to start by acknowledging that the Ngunnawal people, the traditional owners of the lands from where I'm joining from today here in Canberra, and pay my respects to their elders past and present, and the hugely important role that Aboriginal and Torres Strait Islanders play in Australia around as part of our national biosecurity system, both in terms of national surveillance, but also in terms of being Australia's largest land custodians and all the work they do on managing the impacts of invasive alien species on country. So I've broken my talk into 4 areas. The first one is, I'll just talk briefly about a global assessment organized by the Intergovernmental Platform, a Science Policy Platform on Biodiversity and Ecosystem Services on the invasive alien species challenge globally. Then I'll talk a bit about Australian and global impacts, threats, costs and impacts with some data. Then I'll go into the bulk of the presentation, which is around managing both the threats and impacts from a biosecurity and an impact perspective. And finally, just finishing off with a few governance and policy challenges in this space. So in 2023, IPBES published their first global assessment on invasive alien species and their control, which I hope many of you have had a chance to have a look at. It's available just by typing IPBES IAS assessment into Google. I was very lucky to be one of the 200 odd authors, and I led the chapter on management. The global assessment of biodiversity, which came out in 2019, had already identified invasive alien species as being one of the five major drivers of biodiversity loss. And in the context of the assessment, alien species are organisms that have been introduced by human activities to new regions, and invasive alien species are a subset of those known to have established and spread and have had negative impacts on nature and people. And we are very familiar with these in Australia. The threats from biological invasions are increasing markedly in all regions of the Earth. This global data set of alien species shows that in all groups and in all regions, the numbers are continuing to increase with little sign that they're starting to plateau off. Australia and Oceania are no exception, though there is good evidence that our biosecurity system is slowing the pace of incursion. Now, people and nature are threatened by invasive alien species in all regions of the Earth. There are about 37,000 established alien species introduced through human activities worldwide that are known about. And about 200 new ones arrive and are spread every year. And about 3,500 of these are invasive alien species with negative impacts. And the illustration on the right just gives some examples of some invasive species and their impacts on nature's contributions to people, and good quality of life, which are the three primary characteristics or measurable domains that it best recognizes. In terms of impacts, invasive alien species have been involved globally in around about 60% of all recorded global extinctions across a range of groups of organisms. The economic costs are high. They're conservatively estimated to be, and this is going back probably about 5 years now, $423 billion. And the trend suggests they'll increase by around fourfold per decade. And about 85% of invasive alien species have negative impact on good quality of life. As part of the IPBES assessment, we looked at positive impacts as well as negative impacts to be sure that we were providing an objective evaluation. And you can see the negative impacts on the right-hand slides far outweigh the positive benefits that some communities gain from these invasive species. So that's some overarching global perspectives. And I do encourage you to, particularly the summary for policymakers provides a lot of useful information. Now I'm just going to look more specifically at threats, costs, and impacts in terms of some data and some trends. So this is one of our slides we use for the Catalysing Australia's Biosecurity Initiative. It shows that the numbers of threats from exotic organisms and diseases to Australia are increasing substantially through increasing trade and people movement. And they cover all three domains of environmental, plant and animal biosecurity. And we only expect those to increase in the future. And I think a good example of future threats is the H5N1 high-path avian influenza, which continues to threaten Australia's borders. But what are we protecting in an Australian context? Well, we're protecting about a $90 billion ag sector, about $70 billion of which is exported. So it's very important for Australian exports. It's protecting about 1.6 million jobs across the agricultural sector and supply chains. And from an environmental assets perspective, about $6.5 trillion of environmental assets and ecosystem services, and well over 1,000 threatened species that are known to be impacted in Australia by invasive species. From a biological invasions perspective in Australia, if we just look across the different plant groups and what's happening, vertebrate pests, the rate of new arrivals of vertebrate pests in Australia is declining. The pet trade, particularly pet fish, is the exception. around invasive alien plant naturalizations. This is level to increasing at around 15 new species recorded a year. And many of these are already in the country. They just haven't naturalized yet. From invertebrate pests, it's estimated that there's about 2 new species arrive per year, and it appears to be slightly increasing. From a plant pathogens perspective, it's a bit higher because of the ease with which they can blow in on natural pathways. So about 12 species a year, but the numbers are declining. Animal diseases, as I've already shown you, there are new strains that arrive and threatening Australia, and we do our darndest to keep them out. So that's about stable. And marine pests are increasing through marine trade and marine debris, which I'll come back to. From a global perspective, the global economic impacts were analyzed first in 2000 and estimated to be about 1.4 trillion US dollars per year. And the Invacos study, which went into a hell of a lot more detail in 2021, came with a similar figure of around $1.3 trillion a year over the last 50 years. So very similar estimations of costs. In terms of what species are the most costly in terms of taxa, well, mosquitoes are number one, followed by rats, followed by cats, and then a whole range of other invertebrates. The impacts of plants comes much further down the track globally. From an Australian perspective, this is the Australian economic data. Alien pests and weeds and disease cost Australia about $390 billion over the last 50 years, which represents about a 6-fold increase per decade. And the current annual costs are estimated to be around $25 billion a year under this Invacost analysis. And all this is published information. From an Australian perspective, here's a list of the vertebrate pests in declining order of impacts, followed by invertebrates, where you've got fire ants clearly at the top of the list. Unsurprisingly, mosquitoes come lower down in the context of Australia being relatively free of exotic mosquitoes and the diseases they carry. And then for plants too, a range of mostly agricultural weeds causing significant economic costs to Australia. And here's some classic examples that we've faced with we've been working over in the last few years. The arrival and spread of myrtle rust is now threatening near extinction of at least 4 native trees, a number which is only likely to grow. There have been over $1 billion of costs from red imported fire ant, which we're still, some would say, hopelessly trying to eradicate. Varroa mite, a relatively new incursion. This has cost already $33 million. And parasitic witchweed, which has been the focus of an eradication program for some time, has estimated to have cost $7 million. So recent outbreaks and emerging pests and weeds highlight the urgent need to improve our biosecurity. Now, moving into managing threats and impacts. When it comes to management, there are generally 3 approaches. You either focus on managing the introduction pathways, which is where we do in Australia all our prevention and preparedness work, which is the primary role of our Department of Agriculture, Fisheries and Forestry. Also, we undertake a lot of species-led management, from surveillance right the way through to managing at landscape scales, but also site and ecosystem-based management and restoration to respond at ecosystem levels and improve the resilience of those ecosystems to future threats. And the diagram on the right is an example of how these 3 different approaches have been integrated in the Galapagos Islands to help manage their invasive alien species under their biodiversity strategy. Now, this is a figure out of the IPBES report. It is a combination of the biosecurity continuum and what's well known as the invasion curve, conceptualizing the arrival of species and their spread and widespread impacts per area. But embedding into that diagram around the management objectives of prevention and preparedness, early detection and eradication, containment and control, the various management targets across those 4 phases, and the actions to achieve those objectives. I won't have had time to go into them in great detail, but you'll find them in the summary for policymakers. And they really indicate where during those activities, what kinds of management you should undertake and what types of approaches you should be using. Now, when it comes to integrating management across the invasion curve, prevention and preparedness, early detection and rapid response, the front end of the biosecurity continuum, is around the absent and entry phase, where a lot of the work is around introduction pathway management from offshore to border biosecurity. And then through the establishment phase of species-led and pathway management to both eradicate new arrivals and stop their spread within country, through to the more long-term active control, when these are primarily species-led containment and control activities, including biocontrol and site and ecosystem-based management. Now, looking first at prevention and preparedness, widely recognized that prevention and preparedness is the most cost-effective approach to managing threats and future impacts. Though prevention is not always possible, because species will arrive on natural pathways, and prevention is dealing with everything, whereas once it becomes post-border management, it's a much smaller group of species. So prevention and preparedness are kind of generic and high cost, but will have high returns. So it's through import controls, pre-border, post-border, and border and post-border biosecurity, and rapid response protocols and agreements. But in marine environments, prevention is critical, because the evidence suggests that in marine environments and connected water systems, where eradication has generally failed, any other form of management has been largely ineffective, though prevention has been very effective on islands. Now, what's required for prevention and preparedness? Well, it requires effective biosecurity legislation and regulations, like we have in Australia, capacity building, good border inspection facilities, good offshore intelligence gathering and pest risk analysis, surveillance detection and diagnostics, rapid response, technical cooperation, etc., etc. And there are many decision support approaches and tools listed on this slide, which are used during that early phase to support decision making around where investments need to be made at the early phase of the biosecurity continuum. And all of these systems, we go into some detail in our assessment internationally. Surveillance and detection tools is really where new technologies are really starting to make a difference. So these include the inclusion and support of citizen science, crowdsourcing and web scraping of overseas information on new arrivals or species that are spreading, the use of sentinel sites, the use of risk mapping, use of remote sensing and sensor networks and smart traps, and a whole range of other technologies, which I'll go into in a little bit more detail, some of them that are in bold in the next few slides. So sensor networks are increasingly being used to monitor and survey the environment for changes, both in the context of plant health and animal health. And they're applied in the context of small-scale continuous mapping and monitoring, livestock movement and health, and monitoring and mapping other beneficial organisms and pest animals, and increasingly using audio detection in sensitive environments. And hyperspectral imaging platforms are also increasingly becoming available and being used to be able to scan and support remote sensing. And here's a table that summarizes the benefits of different sorts of platforms that are all being used to some extent in terms of remote sensing surveillance, which most of these are increasingly being used in Australia. Satellites are probably the slowest, but they'll come online as soon as Australia has the capacity to do a satellite-based hyperspectral imaging. And here's just one example of satellite imagery used to map gamba grass in northern Australia, using satellite imagery. And the accuracy of this process was demonstrated to be 91%, using low orbital satellites, and the advantage that brings in terms of 5G. Another technology option here is image-based automated identification systems using AI and machine learning. You'll all be familiar, I'm sure, with iNaturalist, which is a key example of that, and uses huge image libraries. And these tools are now heavily being used by citizen science. And when somebody in Australia picks up a high-risk species on iNaturalist, there is now a mechanism where the authorities are notified in real time. So this tool is now being used for real-time detection and surveillance. And then there are the molecular tools, the eDNA barcoding as a way of improving our field-based diagnostics, both for weeds, but also for animal diseases in wastewater systems. These are becoming almost commonplace now. And we have a national reference laboratory in Australia supported by DAF to ensure that capability is developed. But through CSIRO's work, we're also looking at whole genome sequencing and the value of genomics in more general to understand what is outside of Australia and may come in, but also what arrives into Australia and how to manage it. And we used this approach very effectively for the arrival of fall armyworm a few years ago into Australia, where before it arrived, we knew exactly where it was coming from, and we knew exactly which genotypes we would get in the context of insecticide resistance capability, etc. And this is going to increasingly being used to develop a kind of biosecurity tracker, a bit like the COVID tracker systems that we saw during the pandemic. Now, moving on to species-led management and eradication. As many will you, most eradication programs fail. So to run an effective eradication program needs a lot of evidence-based science and ongoing monitoring and high investment. The last individual to eradicate is always the most costly. But it has been highly successful, particularly on islands. Over 1,500 examples of vertebrate eradications now on over 1,000 islands globally, and it's been quite effective in Australia for eradicating small outbreaks of new outbreaks of invasive ants. Though plant eradications and marine eradications are much more challenging. And again, in these kind of contexts, again, autonomous robotics are being used, particularly in the context of environmental weed management, for both detection and mapping, but also eradication, particularly, and a classic example of that is bufflegrass on Barrow Island, but also treatment of existing stands. There are a few examples here. Then when we move on to more species-led management for more widespread control, physical, mechanical, and chemical are still the most widely used control measures, but generally they're short-term in efficacy and regular application is required and quite poor cost effectiveness as a result. Grazing is also used quite widely in Australia as a weed management tool in graze systems. And an example here of where technology is being used is the use of AI platforms to support indigenous weed management in the Northern Australian wetlands, which are known as the supermarkets of the bush. The application of digital support and ICT support platforms has allowed the indigenous rangers in Kakadu to not only understand whether their treatment of paragrass management on the floodplains has been effective, but also in real time to be able to measure the biodiversity benefits in terms of the number of nesting magpie geese. And the application of drones and smart apps in this context really did turn paragrass management in the park from being intractable to tractable, and now is carried out on an annual basis using both drones and tablets to support the indigenous rangers. And here you can see some CSIRO scientists working with the rangers on some of these technologies. Another platform we've been working on in terms of landscape scale management is feral herd management in Northern Australia around surveillance and management, particularly on indigenous lands, otherwise known as space cows. It's a big project funded through DAF with multiple partners, and use satellite tracking of feral herds to not only manage those herds from a conservation perspective, but also in terms of indigenous on the ground businesses for into the meat markets, but also in terms of being able to manage carbon emissions from these feral herds. And it's a technology-based platform with satellite trackers that go on the animals in the field, and the tech-based decision support platforms have been developed with the indigenous land managers who have learned how to use them and have now adopted these as a way of actually managing their business, for not just in terms of feral animal management, but when they harvest, how much it will cost them from a fuel perspective to go out and harvest, and what the meat market prices are in terms of whether it's economically viable. Moving on to other species-led management, we've got classical biological control, we've got sterile insect technique, we've got biopesticides, the well-known viral biocontrol of vertebrates, which started with rabbits and is now moving into carp, and some novel genetic control approaches, which have just got a $10 billion boost, $1 million boost of funding from the federal government just before the election. And that's the use, particularly the use of meiotic gene drive systems to drive feral populations male through a GM-based approach. Though there are existing native natural chromosomes that lead to sex bias in species, and the main target here has been rodents, but the plan is that we'll move into rabbits and then eventually into feral cats. Now, these are kind of technologies all sound really good. They're humane, they're specific, they're self-disseminating, they're not contagious, but they also have a tendency to create panic because they're also uncontrollable. People still consider GM options in an environmental context as being irresponsible, and so there's a big social challenge around their adoption, which is why a lot of the work in this space has actually gone into public acceptability of these technologies way before the technology started to be developed. And finally, in order to get effective management, you need engagement in collaboration with stakeholders, particularly indigenous peoples and local communities, because this is the only way you'll get effective outcomes for management actions. And it also helps with conflicting perceptions and values about species, the ethics of management options, and sharing science across the local knowledge systems. And in my few minutes towards the end, I'm just going to cover off on a few governance and policy challenges. So through the large report we did with IPBES, the governance team recognized that integrated governance is the best way to support strategic actions to both prevent introduction and impact of invasive alien species. This is through enhanced international and regional coordination, through developing and adopting tractable national invasive alien species management strategies, through sharing efforts and commitment, through improving policy coherence across jurisdictions, through building engagement across all stakeholders, and particularly indigenous peoples and local communities, through resourcing innovation and research and technology, and supporting data innovation systems and infrastructures. Now, data information systems are critically important in this space. I didn't have much time to go into them, but maybe we can talk a bit more about that in the questions. And there are, of course, as a result, a number of international sanitary and risk-based regulations, measures and standards, and guidelines and treatments that support biosecurity. The IPPC, International Plant Protection Convention, is there to manage plant-based trade. The World Animal Health Organization manages animal diseases, and CITES manages the spread of endangered species around the world, which includes the challenges associated with the illegal trade in exotic organisms. And the prevention challenges here are illustrated here. So in terms of terrestrial systems, We have trade, but we also have e-commerce and the illegal pet trade. The illegal pet and plant trade is now the third biggest illegal trade globally after arms and drugs. And so it's very hard to manage in terms of the threats it creates to new species arrivals. And in the marine environment, there are still lots of challenges around biofouling, marine debris carrying species, and again, the pet trade in marine species. And in an Australian context, there are a number of important documents and strategies that support the need for a transformational approach to our national biosecurity system. And the most important of these is the National Biosecurity Strategy, which was launched a couple of years ago and is driving has 6 action areas and a whole range of action activities that are in the process to try and deliver and support a better system. And finally, I think I'm on my final slide. In undertaking these kind of technological approaches, it's very important to undertake responsible innovation. So not just for commercial outcomes, but for public good outcomes as well. And CSIRO has been leading, has a leading program to ensure that from an innovation and technology development and operation and productization process, we're taking a responsible innovation approach. And I'll finish with this slide and just read off it. There is compelling evidence for immediate and sustained action to address the issue of invasive alien species and diseases, and with sufficient resources and long-term commitment, preventing and controlling invasive alien species are attainable goals that will yield significant long-term benefits for people and nature. And that was our concluding statement as part of the BESS assessment. And I'll leave it there. Thank you.
Thanks very much, Andy. That's great. Um, well, we've got no questions coming in, but I'm going to, as chair, I'm going to start with a couple, and all these documents sound great for those of us who are interested in policy and governance frameworks in particular. But the issues that we've got, we'll just take fire ants as a current example.
Yeah.
What's hitting the press at the moment is that people do not want government inspectors, government workers in the eradication program on their land.
Yeah.
You know, the people who are working in that eradication program currently have to be escorted onto some of the properties, etc. So we've got a gap, at least in public understanding.
Yeah.
And this may go to lack of long-term education or whatever, but the point is the drill down. So you're talking about working well with Aboriginal communities, Indigenous communities, local owners. That's fantastic. But even in the farm sector, which ought to be very aware of all these issues, as opposed to city slickers like myself, there doesn't seem to be that level of understanding. So what does that mean for resourcing and the direction of your resourcing? That's a fairly big question, but can we get by in the way we're doing it now?
Well, look, I mean, so the majority of the funding in this space still comes from the public purse, right? So if there are highly specific challenges for the ag sector, then of course they invest in them or they co-invest in them. The RDCs are half funded by government, half funded by industry levies. But most of the strategic work they fund the RDC's fund comes from the government investment. And obviously, as I've skipped over, but gave the key message, you cannot deliver an effective management program unless everybody is on side. And I think one of the challenges of red imported fire ant is that the program's been going on for so long now, with really very little signs that it's achieving its targets, that you're losing a lot of trust in the stakeholders who have been continually have to be continue involved in that process. And that's why you need in all these programs to build that trust and bring those people on the journey from start right through to finish. Because if you lose the trust, as they may be starting to now, that's going to massively reduce your chance of an effective outcome. An example where it worked quite well, I think, was on Lord Howe Island, where they undertook rodent eradications. The first large Australian island where they undertook rodent eradications, where they'd spend a lot of time engaging with the local community, and while it was a long program and it cost a lot of money, it's been quite effective.
Yeah, and we can think of Antarctic islands as well, like Macquarie Island with cats
Yeah,
and foxes,
yeah, there
and
it's easier because there are very few people that are there to complain, though, John.
yeah, I agree with that. And the New Zealanders are doing a good job because they are a smaller island, a smaller landmass, and they've
Mm.
been working very hard on that. How does our investment, our annual investment or expenditure in Australia compare with New Zealand and other countries that might want to compare ourselves with, please?
Well, because both Australia and New Zealand really value our national biosecurity system, and we do it because of the trade benefits it generates for us. So it's an economic investment to support our preferential and high levels of trade. We put a lot of money into it, right? I think it's estimated that, and I'm maybe going off the cuff here a bit, but Australia probably spends somewhere close to $1 billion a year on our biosecurity system. But the economics of that suggests we get about $10 billion a year of benefit back. So it's really, now we've got some reasonable data to suggest the cost benefit is a value. And I think New Zealand probably invests of the same order, based on the side of their economy. Now, I don't think any other country in the world best invests anywhere near that amount of money in this biosecurity systems, for probably primarily two reasons. One is that, most countries aren't islands. It's easier to do it when you've got an island, but also because the amount of agriculture they export and the markets they can access through their exports are not privileged so much by the biosecurity status of a country like Australia, which has been able to keep so many of these global pests, weeds, and diseases out.
Right. Okay. Um, I'm going to turn now to some of the questions that have come in on the chats.
Sure.
Um,
I've got the
and
chat open. That's helpful.
sorry.
I have the chat open if that's helpful.
Yeah, that is, and that allows you also to see what's there. But we might just start at the top. When you said citizen science, what do we understand by citizen science, and how marshaled is that?
Okay.
Is citizen science dependent on having a CSIRO or Department of Ag person in the team?
Oh, no, 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 by no means. Um, so you're going back to New Zealand. New Zealand ran an exceptionally good public awareness campaign around biosecurity, in which they talked about 5 million pairs of eyes in New Zealand there to support our national biosecurity system. Now they're talking about every citizen having a role to play, and um, uh, the public have also always been very keen to have a role to play in detecting new stuff that comes in, and some of these new technologies like these image-based detection systems, that you have on your smartphone, like iNaturalist, can allow individuals now to be able to operate completely independently of any expert advice through getting the what they've photographed identified through these platforms, and then loading it onto the platform. And I think those kind of technological approaches have really allowed every interested individual to have access and be able to make a contribution. This isn't just for biosecurity; it's also for biodiversity as well. Um, but empowering our countrymen to be able to do that more and more is going to be highly effective for our biosecurity system, because if you talk to anybody who's an expert in surveillance, we mostly pick up new stuff through general surveillance, through the involvement of the general public, than we do through targeted surveillance around particular threats. So citizen science can be done by any individual now because of technology, and it has a critically important role to play nationally. I'll give you one counter example. I just popped into my head. Um, of how it could be used, but it's not being used. Red imported fire ant was detected in Italy 2 years ago in Sicily. The scientists that detected it decided not to tell anyone until they published a paper, to the point where the outbreak is now beyond control. But they look back and realize that it had actually been picked up by an iNaturalist about 6 months prior to even the scientists detecting it. So that's the power of these tools in terms of being able to provide real-time information. Just nobody looked.
It's also a comment on the way we rank publications as essential for promotion. Yes, okay. Um, Coming back on fire ant, since this is a really topical issue, and the Australia Institute, since I'm an economist and cut my teeth examining the entrails of Doug Waterhouse's activities. Um, uh,
Very useful work, John.
Thank you.
I still refer
Yeah,
to it.
good, excellent. I'm glad I'm not totally forgotten. But the point is that red fire ant is there. We've had a benefit cost study done by Canberra. We've had a benefit cost study done by the Australia Institute. And like all good benefit cost studies, they give the answer that each group wanted. Is that too cynical?
I couldn't possibly comment. You might say that, but I couldn't possibly comment. Um, I think the scientific evidence that we could achieve eradication of the red imported fire ant outbreak around Brisbane has been largely ignored, and they're carrying on regardless, and managing to attract more investment from government to do so. So there does become a point in which the evidence, if it's not convenient politically, is ignored, and they set themselves, what most scientists would see as unrealistic targets.
Right. Okay. Yeah. And get people who are sovereign individuals very upset in
Yeah,
Queensland. Yep. Okay. Um, Coming back to our prevention at the border, which we've relied on very much in the past. Um, you know, more and more people come by plane. There's a question on the
yeah,
chat there which says why don't we spray airplanes anymore? But this
yeah,
whole border issue for us is of great importance. We've got the aircraft, but here in all our quite pristine environments in the marine area are now infected by pumping out of bilge water, etc. It may be
yeah,
illegal, but it still happens.
yep,
Um, so as usual, the question is the surveillance inadequate or
yeah,
are the penalties inadequate? And as an economist, I can tell you that having huge penalties but low surveillance and enforcement means that the penalties are irrelevant. So
yeah.
what's going on there? What do we are we in an optimal position currently on border security, or do we need to dramatically change our ways and perhaps increase our resourcing?
I don't think we're anywhere near optimal, on the basis that, as I said earlier in the talk, the threats are increasing, and we're still spending the same amount each year. And a continent the size of Australia to undertake effective surveillance, particularly in marine systems, is incredibly challenging. Um, and we've never resourced that enough, in the context that if something were to arrive and establish, there's very little afterwards we could do about it. So I think there's some important messaging for governments there in terms of how you do it. But my role is very much around promoting and supporting the development of technologies that will make that much more efficient. Right. So
Yeah.
it is entirely achievable by 2030 that we could robotically surveil all of our ports and main transit areas, marine transit areas, using state-of-the-art genetic meta barcodes, and be picking stuff up and doing surveillance in real time. There's no technological impediment to being able to do that, but somebody, of course, still has to pay for it. But we've clearly got to move away from where it's all being done by divers and using more manual approaches.
Right. Okay. So that's on the surveillance side. That's clearly on the boating side, if I can put it that way, on the shipping. What about and how is that running in the northwest, particularly where we've got massive ships going more regularly? We'd have greater tonnages going out of the Pilbara, etc., than we would have out of Sydney, I would have thought.
Probably not qualified to ask, John. I'm looking at James Ridgell Smith because he can probably answer that question better than I can. But I mean, my understanding, of course, is that those companies do tend to they have highly strict biosecurity protocols as part of their freedom to operate in those regions, and one assumes that they abide by them.
Right. Okay. Right. Staying on governance for a moment, and then we'll run through the questions. And I'm very pleased to see that one of the questions is from Brian Timms, who I hadn't noticed earlier. Glad you're out of your off your couch, Brian. Um, okay. So my other question is, under our current arrangements, as usual, the federal government has powers, but not feet on the ground, and the feet on the ground are generally the agricultural departments of the states,
Yep.
right? And so there's
Well,
a
they have quite big teams at the borders, right?
yes, that is true.
Yeah,
Yep, and a great television program.
yeah.
Yeah. Um,
Not just in the airports, also in the ports, of course. So
yes,
yeah,
yeah. But the question comes down to how do we resource this Commonwealth state interface, and are the agricultural departments, which have been our traditional feet on the ground, are they the way to go in the future? Yeah. Or is it a more mixed model?
oh, I think it has to be a mixed model. I mean, as many of you will know, a lot of the expertise sits in the state departments. You can become a career scientist or a career bureaucrat in a particular area in a state department, whereas in the federal departments, people are moving around all the time, and very few of them actually pick up any long-term expertise and experience. So I think the state departments are probably where the diamonds are, but it has to be a mixed model.
Right. And can you also comment on things like you've mentioned, and it's in the flyer, H5N1, and the ABC recently ran a nice program showing just how close H5N1 we've got sea lions dying,
Yeah,
some species of penguins, not others, etc. But all around us, whether it's South America, whether it's the Antarctic Peninsula, whether it's Antarctica itself, and then we've got all the islands which start to come up, Kerguelen and so on,
yeah,
coming up towards us. So this is sitting around us and could arrive at any time via mammals, let alone via birds.
yeah.
And we have migration, of course, coming out of Asia, down, etc. That's following a different model, isn't it? Isn't there a major initiative, $100 million initiative in
So obviously Australia is extremely concerned about the threat, and it's going to be a when rather than an if of H5N1 arriving in Australia. And you could argue that $100 million in that context is quite a small amount of money. But there's also very little they can do, right? There's not actually too much you can do to prevent it if it's coming in on a natural pathway. Once it arrives in a country the size of Australia, how long will it have been in the country before you actually detect it? So a lot of the investment has gone into working out where the risks are. What are the species most likely to be at risk? What are the pathways, and what are the localities where it's likely to arrive? A lot of that work's been led out of Deakin University, and they've done some really neat stuff on identifying which groups of birds, for example, are likely to be most the carriers of it, and where it's likely to arrive. At an operational level, the government is trying to work out still basic issues like what should somebody do if they find a dead bird? Um, um, should they pick it up and put it in a bag and take it to someone, or just photograph it on their mobile phone and upload it to the Atlas of Living Australia? Well, the right answer is the latter. Um, but ultimately, there's not much they can do apart from try and track it and get on onto it and then deal with the consequences. There's also a lot of work going on around our ability to vaccinate threatened birds in Australia, or species that are likely to be susceptible if we need to.
Well, as someone born in Western Australia, I'm particularly concerned, of course, about black swans.
Yeah, yeah,
Right, and we know that the black swans have almost zero immunity to this type of thing because of their you might say primitive or very early genetic structure compared to the
yeah,
European swans.
yeah.
So so you know as an West Australian or sometimes West Australian, you know, can we vaccinate? Is this practical?
Well, it's a scale thing, isn't it, John? I mean, we can vaccinate, but can we vaccinate on a scale that's going to be effective? It's the similar kinds of questions that go around the department in the context of a foot and mouth disease outbreak. You know, vaccination is probably your most socially acceptable strategy versus mass culling, but how can you roll it out fast enough and extensive enough to actually make a difference?
Right. But in the case of cattle, everybody would be concerned. Yeah, we know that vaccination programs, bovine brucellosis, tuberculosis, etc., have been successful in the past. And we know that
Yeah,
farmers don't really want to see dead animals. Whereas with something like black swans or other susceptible species, which are wild, they don't have they don't have a commercial champion.
true.
Right. So, can we set up remnant populations so that they can bounce back thereafter?
Yeah, I mean, my guess would be as good as yours, John. I haven't really, I'm not deep dived into that particular area.
It's a frightening possibility. Um, okay, so just returning to the chats, and you can see some of these. So, we might basically have a quick look at that.
I can start with rabbits and Salvation Jane. Do you want me to tackle that
Excellent,
one?
excellent.
So they're both those programs are extremely have been extremely effective. We've never had a huge amount of money to actually do the long-term monitoring and evaluation, but certainly all the uh, uh, anecdotal evidence for Patterson's curse from across Australia suggests that the program has been extremely successful. On a scale perhaps only number two to prickly pear in terms of effectiveness. Rabbit biocontrol has the ongoing challenge that about every 10 years, the rabbits build up some form of resistance to what's been the most historically effective approach. And so you always need to be investing in what every 10 years, what are you going to do to maintain rabbit biological control effective? And it has been maintained to be quite effective. And there's a research program in CSIRO looking at can we actually use gain of function approaches around some of the diseases we've already got to make them more virulent in the future.
Right. I thought that had gone out. I thought gain of function was a phrase we're not allowed to use anymore.
Well, yeah, but then it sort of came back into fashion. It depends what's going on, really. I suppose if it's controllable, then it's acceptable. Now, why do we spray aeroplanes? I can't answer that question, I'm afraid. I asked the same question myself. I would though suggest that aeroplanes are probably not a very that that important a pathway of introduction. Containers are much higher risk, so we should probably be worrying more about how many containers we can inspect and what technologies we can use to do that efficiently.
Right. Well, are we doing are you doing work or are you funding work on containers? Because that is a
Oh, well, the
critical
Department
thing,
of Agriculture definitely is. Yes, absolutely. Yeah, yeah,
right? And that's also relevant to drugs, of course.
yeah, yeah. Well, exactly. I mean, if you use the same approaches to manage the big three illegal yeah, trade contexts, then maybe you'll be able to be able to chew things at scale. I've no idea why the penalties are so small on passenger luggage. That's way out of my area of expertise. What's the
Right.
next one? Is there any way of permanently controlling the regular mouse plagues in cereal storages? Well, there is a large program in CSIRO that's been working for quite a while on mouse plagues, and it's that team which is now looking to develop a genetic control approach for rodents. Australia is the has the first proof of concept for a working gene drive system in a mammal, and it is in the house mouse. And There's a lot of work now going on to see about how it could be controlled in the context of the environments into which you want to introduce it to drive the resident populations male and therefore causing the populations to crash. But I think it'll be a long while before it's used in the context of uh, of the mouse plagues that happen around Australia, because again they tend to come and go in time frames that are relatively short compared to the impacts of these kind of management approaches.
Right. There was, just noted on the way through that there was an interesting ABC documentary on landline showing how damage could be reduced by using wheat germ oil to smother the field so that the mice didn't burrow in the same way as they used to. Yeah.
Well, I mean, the last time I talked to that team, they said they've come up with a formulation that would be much more effective for managing mouse populations in ag sectors, but they've been waiting for APVMA to approve it, and it's the resourcing constraints in that regulator have made it particularly a long process to be able to get that to growers.
Okay, good. That may be why they decided to get some publicity.
Now, the
Yeah.
next one is there a mechanism for effective implementation of the biosecurity strategy and roadmap? Um, my view is that there is a mechanism, but it's not resourced well enough, either at a policy scale, a policy level, or at an evidence-based science level.
So just can we just stay on that? I mean, one of the as an economist, I can tell you that one of the most effective things that came out of the the Hawke Keating was national competition policy, and there was a mechanism which ran through the National Competition Council, and there were payments to the states that did good things, and there weren't payments to the states that didn't. Money was withheld, and there was a definite carrot and stick approach. Do we have anything like that with our biosecurity strategy and roadmap? Or are we way back from that?
Well, whether I wouldn't go as far as calling it a carrot and stick approach. There are certainly plenty of incentives now around for companies and countries that import regularly into Australia to be able to ensure that their trade is not held up by the biosecurity system. Um, 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 so incentives is, I think, probably where it is now. The government has tried a couple of times to bring in tariffs, or not tariffs. Tariffs is the wrong word. That's a Trump word. Um, but you know what I mean. To charge importers for the biosecurity services that the government provides, and each time it's been knocked back. So they're trying to come up with ways to financially incentivize it as well.
Yep. Okay. Um, there's a question there on equine influenza,
Yep.
and I'd be grateful if you could answer that one. But I'd like to add a second question, and which can be in sequence, which is flus. We've mentioned H5N1. We've already got avian bird flu, not the high pathogenic, but we've certainly got it in the Australian egg industry, mainly because we've gone for very open range egg production. And that's good, but there are impacts there. But then we come down to we've all had COVID, and we've many people this year have had influenza B, especially, etc. How does all this flu stuff fit together? But first, could you please direct it to the equine issue?
Well, everything I've learned about influenza, I learned from Bruce Christie, who used to be head of biosecurity in New South Wales. So if you want to understand more about equine influenza, invite him to give you a talk. Certainly not my field. Um, I certainly think that they learned a hell of a lot from the equine influenza outbreak in terms of how to more effectively manage, and they were pretty lucky, I think, in terms of being able to respond and achieve the outcome they did. Um, but as I say, I'm not an expert in that area, and you should invite Bruce in to talk about that if that's an area of interest.
All right, good, thank you. All right. Um, and then there's this question on schools and the public, iNaturalists and tech savvy kids, but it's also not just being tech savvy, it's having this idea that our biosecurity really matters, that
Yep.
the integrity of our environment, our more natural environment, is really important.
Yeah, look, I mean, I think there's a lot of evidence now that the younger generation are realizing that getting out and about and bird watching has suddenly taken off again in the next generation. So there's a role for them to play and a golden opportunity for them to play a role with all of these technologies. And schools I'm sure, do a lot to encourage and support that. Through school projects and so on. But as I say, I think if you put something and make it and set a bit of a competition around it or through an app on an iPhone, the kids will come running just to participate, is my guess.
Okay. All right. All right. Um, I'm
Okay.
looking at the time, so I'm just going to look to see if there's any other questions
The
down.
last question's on cane toads. I can talk a bit about cane toads.
You love questions on cane toads, right?
Well, I kind of, it's both the bugbear of any biocontroller, but also such an interesting system to talk about, right? And let me just remind everybody, it wasn't Ciro that introduced the cane toad, and the cane toad was introduced well before there was any regulatory system around whether we allowed to bring new organisms into Australia or not. So we can hardly be blamed on the biocontrollers for the release of cane toads. But there is some really exciting and novel work going on around cane toad management at Macquarie University, led by that well-known figure Rick Shine and some young geneticists. They have produced now tadpoles of cane toads that don't metamorphose. They stay as tadpoles for their entire existence. And what do tadpoles generally eat? What do cane toad tadpoles generally eat? It's other cane toad tadpoles. So the strategy they're working up now is can they introduce these genetically modified? They'll need to go through all the regulatory approval processes, but from a scientific could it be possible approach, could they introduce these genetically modified tadpoles that will never metamorphose and reproduce into key water bodies to gobble up any cane toad tadpoles that are deposited into those water bodies, which I think is an interesting approach. Probably better, more interesting than Rick Shine's previous work on tadpole on cane toad sausages. But anyway.
Question though, the cane toad itself has gone through considerable, uh, what you might call it natural selection.
Yep.
Cane toads are now bigger, longer legged, able to cover bigger distances, and quite possibly less dependent on immediate water. They've been able to travel across the north.
Yeah. Though that what they call rapid evolution, John, is short term. All right. Once it's only during the expansion phase. Once they settle down in a particular area, they go back to normal cane toad size.
Oh,
So it's
really?
simply a short term, yeah, it's a short term evolutionary change that comes from the benefits of migration, if you like. Once they're everywhere, that benefit no longer provides enough of an evolutionary pref, uh, pressure to maintain those species, those individuals. Sorry.
So, what you're saying is that those cane toads, which have evolved their longer legs,
Yep.
might well throw back to what we call perhaps more
Yeah.
normal cane toads,
Yeah.
and that they will be also outcompeted eventually by the more normal cane toads when they're back in good conditions.
Yeah. In a nutshell, I think that about sums it up.
That sounds like what happens on the Galapagos with the swing between the beaks.
Mm.
Yeah. Okay. All right. Um, Any other questions I really want to find out? I can't see any more. I could go on for a long while, and we could go through the role of how did various things escape, but we won't go through the disasters. We might do that. That could be too depressing. But can you just tell us about myrtle rust, and then I think we should call it a day. If that's
Okay. So myrtle rust, as all of you will know, has spread very extensively up the east coast of Australia now. And a lot of work has gone into identifying those species that are of native tree Myrtaceae that are at risk, particularly in the context of likelihood of extinction. The Department of Environment, Water and Climate Change, or whatever it is developing a key threatening process around myrtle rust for more naturally. Obviously, the big concern is its arrival into Western Australia and all the native Myrtaceae of Western Australia. Um, um, but I think the enough sciences has been done for us to be able to potentially anticipate the threatened species that would be at risk, before myrtle rust arrives, given a good understanding of the pathology of the system. But again, it's one of those cases of a disease getting in on
He wasn't taking
a relatively unknown pathway, possibly a surfboarder's towel from Hawaii, um, and spreading throughout the country with very little we can do to stop it.
Right. Well, that's a bit gloomy, but strength to your arm with your project with DAF. Um, I should give you our thanks and wrap up. Um, we always pride ourselves on starting early. I see we're 7 minutes over, and my apologies
That's all
for
right.
that. But
No, it's
thank
been fun.
you very much indeed for giving us that framework. And we're going to be all watching, I think, the governance and resourcing side and trying to understand that more.
Okay, well, it's a great pleasure to talk to the people online in your club, and if there's any way I can support you in the future, don't hesitate to ask.
Thank you very much, Andy. That is most generous, and I'm still going to ask you sometime later about how you managed to pull off the south of France as a place to work.
Well, James, ask James. He knows all about that. I met James in the south of France for the first time, so he
That's
can fill you
right.
in on that.
All
I
right. Thank you
remember.
very much.
Okay, bye now.
Thank- James, do you want to expand on that now that Andy's given up the
Yes, I went down to Montpellier to have a look at the dung beetle program, and it's the first day Andy arrived. He came from England, so he was given the job of showing me around.
So I've known James for 38 years. That's what that tells you.
It's a thought, isn't it?
Anyway,
right.
I've got to drop off for another meeting, but thanks, John. See ya.
Thank you very much, Andy. That's great.
Bye.
Right. For those of you who are still there, our next speaker next month is Dylan Keith. Dylan is a member of the Athenaeum Club. He is also in charge of AI development inside the National Australia Bank. So I think this will be a really riveting picture of the practical application of AI. So I thank you for joining us tonight, and I look forward to seeing you next month, indeed. So thank you all.